So today we are looking at the relative position and velocity of vectors. So first we've got two position vectors are given by A, 3i take 2j, and B, negative 2 plus 4j. Now we know position vectors are given as a relative point from the origin. So if this is our origin here, we know A is relative to the origin, so it's saying from the origin we've travelled 3 across and 2 down. And we know B, relative to the origin, is negative 2 or 2 to the left and 4 up. So we describe position vectors as being relative to the origin. Now what we can also do though is we can describe these positions that we've now obtained as relative to one another. So if I wanted to describe the position of B relative to A, then I would need a new notation. And we touched on this briefly at the end of chapter 4. But it's this notation here, so where we say the position of B relative to A, all right, which is the same thing as AB. So it means if I am standing at A, how would I get to B, or what is B's position relative to A? Now, it's always good when you're doing vectors to sketch things and check you agree which way the nose to tail would have to be to get where you want to go. But because we do like to save ourselves a bit of time, basically you can just remember that if you're doing AB or B relative to A, it will always be negative A plus B. Okay, so if you can remember that, that saves you time. If you're ever stuck, you can't remember what order they should go, then you should always be doing a sketch and going, all right, if I want to go from A to B, then obviously it's going to be negative A, so my nose is pointing that way, positive B, so my nose is pointing that way, and obviously the resultant is going to be pointing that way as well. Okay, so just remember, B relative to A means the same thing as AB. So in our example, we can use the two vectors that we have got. So we want positive B, negative A, and we get B relative to A is negative 5, 6. So what that means is if I am standing at A and I want to get to B, I have to go negative 5, positive 6. Okay? So that's looking at positions. We can also look at this in terms of velocity. Okay, so I guess the most important one to think about is this. If you're driving in your car, probably a freeway situation is a better example because there's a lot of traffic and you can see what's going on. When you're driving along the freeway, if everyone's doing the same speed, it looks like no one's moving faster or slower, doesn't it? So if everyone's doing 100 kilometers per hour, you should be driving parallel. And it's only if someone's going a little bit faster, so they say they're doing 103, then they would be creeping past you, so they would be going 3 kilometers more than your speed. So this is what we're kind of talking about when we say relative velocity. So we'll look at a few simple examples too. So say you are just sitting in a chair and a car's coming towards you. Slightly terrifying prospect, but there we go. So if a car is just driving at you at 60 kilometers per hour, then obviously it's going to look like a car coming at you at 60 kilometers per hour. However, if you were also in a car and you were driving 40 kilometers per hour and the other car was doing 60, what would it look like this car is doing now? So hopefully you can recognize that if that's 60, and obviously this is going to be faster because you're both coming from both directions, now it's going to look like this car is coming at you at 100 kilometers per hour. And then if you were doing 40 and this car is doing 60, again, we can see we want to work out the difference. So obviously it's not going to be looking like it's driving 60 away because you're trying to go towards it, but what would be happening is they're obviously going faster than you, so they would be getting further away into the distance, but only by 20 kilometers. Okay, so we'll go obviously in more detail in the next slide. So in each of these situations, ideally I would like you to pause the video at this point and see if you can work out what you think the relative velocities are to you. So in terms, we'll just keep it simple for now. So saying from you, according to you, what does the other car seem to be doing? So pause and see if you can work these out. So hopefully you paused. So first one, you should have got that the car would look like it's travelling towards you at 180 kilometres per hour. In the second one, because you are going faster than the car, this car would look like it's coming towards you backwards, 20 kilometres an hour. With this one, because you're going in reverse and the car's going 100 kilometres that way, it would look like the car is travelling 110 kilometres in this direction, okay? Next slide. Again, could you pause and just predict what you think is going to happen for the next three? Okay, so this one, hopefully you can see the car is travelling away from you at 40 kilometres per hour. This one, you're doing 10, that car's doing 60, so it would look like it's coming at you at 50 kilometres per hour. And then finally, if you're both doing exactly the same speed, like that situation on the freeway, it would look like neither this car isn't moving relative to you. Okay, it would look like it was just standing still because the distance between you would stay the same. Okay, so just a bit of real life application of what we're looking at when we're looking at relative velocity. All right, last slide for these sets of notes. So let's now look. So if we're on a ship and it's travelling with a velocity VA. So generally when we're looking at velocity vectors, we use this notation, VA. And when we're looking at positions, we would use RA, so just keep that in mind. And someone on another ship of a velocity of VB would appear to have this relative velocity. So same as positions, so we're saying B relative to A. So if you're standing on ship A, what would it appear that the velocity of ship B would be? So same thing, we'd take B, add A. Sorry, take A plus B, sorry. So if your velocity on the ship that you're on is 3I take J, and the velocity of the other ship is 5A plus 4J, and then we're going to have a look at a third velocity in a second. So first one, B's velocity relative to you, which is A. So it would appear the ship is heading off on a velocity of 2I5J. If we then had another ship, ship C, so A's velocity relative to C, so if you are on ship C, then we have relative velocity of 7.2. And then finally, if we had a fourth ship, VD, and we're told the relative velocity relative to C, which we've been given, we should be able to work backwards to find out what this fourth ship would be. So if I know C's velocity relative to D's velocity should be negative D positive C, I know that if I rearrange this, I'm trying to find the velocity of D. I know the velocity of C, and all I had to do was switch the positions of those two, just using algebra rearranging, throw in what I know, and then I can work out the velocity of D would be negative 2, 9. Okay? So that should be enough to get you started on 6A and 6B 1 to 10. I'll post another video soon which will help you finish the rest of 6B. Right, thanks guys.